everybody, welcome back to Leetcode Simplified. I'm Alan and today we will be tackling Leetcode 507, perfect number. Determine if n is a perfect number, a positive integer that is equal to the sum of its positive divisors, excluding the number itself. Let's look at the perfect number 28. What are the divisors of 28? 1, 2, 4, 7, 14. Sum all the divisors of 28 equals 28. What are the divisors of 6? 1, 2, and 3. Sum all the divisors of 6 equals 6. So 6 is a perfect number. What are the divisors of 8? 1, 2, 4. Sum of all divisors of 8 does not equal 8. So A is not a perfect number. So the rule is clear. We need to find all divisors of n except n itself. Sum them up and check if the sum equals n. Because divisors come in pairs, if d is a divisor of n, then n divided by d is also a divisor. For example, 2 is a divisor of 28, then 28 divided by 2. 14 is also a divisor. 4 is a divisor of 28, then 28 divided by 4. 7 is also a divisor. 2 is a divisor of 6, then 6 divided by 2. 3 is also a divisor. So we only check divisors up to square root of n because every divisor below square root of n has a partner above square root of n. By the time we reach square root of n, we already found all divisors. Let's implement our logic into Python code. First, number 1 is not a perfect number because sum of its proper divisors is 0, not 1. Initialize a variable to keep track of the sum of divisors. Start with 1, since 1 is a divisor of every integer. Now we're going to check for potential divisors from the range 2 to square root of n. If divisor divides n evenly, add both divisor and divide divisor to sum. Notice that we use integer division to make sure we're adding whole numbers, not floats. At the end, check if n equals sum of its divisors. Okay, let's try this version. Submit. Boom, accepted. This code works 100% correctly, even though perfect square like 9, 16, or 25, the square root is added twice in the sum. For example, the sum of divisors of 9 becomes 1 plus 3 plus 3, which is not the true sum, 1 plus 3. However, for the purpose of perfect number checking, this doesn't cause wrong result because no known perfect number is a perfect square. If you want a version that is 100% technically correct, just check if n is a perfect square. If it is, add only the divisor once, since divisor equals n divide divisor. If n is not a perfect square, add both divisor and its pair. Alright, let's try it. Submit. Boom, accepted. And that's it. Clean and simple, perfectly matching the math we discussed earlier. The time complexity is big O of square root of n, because we only check divisors up to square root of n, which is much faster than checking all numbers up to n. And the space complexity is constant big O of 1, since we only use variable n and sum. If you found this explanation helpful, don't forget to subscribe and check out the playlist for more Leetcode problems explained simply and clearly. I'm Alan and this was Leetcode Simplified. Thanks for watching. I'll see you next one.